Good afternoon, everybody. It's a great pleasure to, have the chance to present this efficient confluent edge network project, or in short, ECO-eNET. My name is Paolo Monti. I am the project coordinator, and I'm from Chalmers University of Technology. What I had here is, just like a quick summary of the project information, but Marino's already provided this, so there is no need to go over it. I already introduced myself, so I just wanted to add that the technical coordination on the other end is with Daniel Kilper at Trinity College in Dublin, and he's actually the, let's say, the system and technology expert in the project. So moving on to the consortium, we also have 11 partners, as the project was just introduced. We have a nice mixture between academic partners, operators, system vendors, and SMEs. Our partners are more or less distributed in 8 countries. So we have Trinity College and Embryonics in Ireland. We have Chalmers, where I'm from, in Sweden, the University of Bristol in UK, IASA, and it was Cosmote at the moment. I think it's OTE now in Greece. ETH and Polariton in Switzerland. In Estonia, we have Taltech and Aditran from Germany. So I just mentioned before, we have both larger companies and SME into the project. So maybe moving on to more technical consideration, what I would like to just introduce here is the motivation for why this project exists and what is the main intuition behind that. And basically, what actually triggered this idea was the fact that we can recognize today 2 main pushes. One, we've been already discussing this quite a bit so far, is the fact that, at the edge network, we have this need for the additional capacity that, it's even greater than in the case of 5G and beyond 5G network. Of course, this put together with the need of low latency, high availability, low energy efficiency. And we already know that, or we identify optics as, or optical networks as a good candidate in actually to fulfill all these requirements, but at the same time, they are very costly. They cannot really be deployed that widely as in access edge it is needed. We have a fixed wireless solution that actually can help with this. Sub-terahertz or terahertz communication, free space optics. Those are very agile and flexible solutions that can help. But the integration between optics, as we heard just in the introduction of the stream, the integration with optics is not still that mature, right? So this is one aspect we want to look into. The other is the topology itself of this access. So the fact that from legacy application where the data center was far away from the user, we had like this 3 structures, so a lot of north-south traffic. But now we know that especially in 5 and 6G scenario, we're going to have a lot of edge data center basically within the edge network, the access network itself. So a lot of east-to-west traffic will take place, but in a 3 network, this doesn't really cope well, right? So what we need at the end is a mesh that can that can be deployed possibly in a flexible and a scalable way, minimizing energy consumption and cost. And this is basically where ECO-eNET comes into. So what we would like to do is actually develop this edge network that is based on the flexible and scalable high capacity transmission technologies, able basically to provide the performance parameter that I just described, with on top, let's say, an orchestration framework based on AI, that actually then orchestrate resources across the mobile, the fixed, and the compute domains. And how do we then enable this mesh networking? Well, we envision this confluence of the radio fixed wireless, free space optics, and let's say WDM transport all together that can be activated as needed. It can be steered, of course, in terms of wireless resources as needed, in order to provide the connectivity that we want. So confluence from our point of view is basically, our confluent transmission refers to a system that is actually natively able to support these multiple transmission media and their signals. So we see it as almost like a step forward compared to conventional convergence. And you can see an example here what we mean, right? So an end-to-end service where we transmit data and control signals regardless of the technologies that we are using. And this is what we would like to ultimately achieve with the project. And as you can see, basically here, this service can go over different type of technology simultaneously, can be steered as needed, depending on the condition of our confluent mesh. So, and yeah, this is the overall, let's say, concept with the key innovation. So we are envisioning this massive MIMO at the, let's say, wireless side or the far edge. With the transport that is the composition of this FSO, radio fixed wireless, optical resources, possibly using optical spectrum as a service, on top of which we can put our services through some kind of method for optimized slicing. And then, as I already mentioned, AI that it is used to basically stitch together everything that is needed. AI will have to be very performing, but on the other end, depending on the edge node in which AI will be put, there might be different constraints in terms of computing power. So again, we will have to look into also ways to actually orchestrate the AI itself. So that's why we will be talking about the federated AI and maybe split computing, where we divide maybe the various models depending on the constraint of our system. So focusing a little bit on which are the technologies that we will be interested to look into the project. I already mentioned both the radio fixed wireless and the FSO. So here we're talking about performance that are a little bit beyond the state of the art. So higher rate, different frequencies. For the FSO, the at least ambition is to get to this terabit per second over 1 kilometer type of transmission. We would like to also look into the possibility to have hybrid links where we combine together radio fixed wireless and FSO, both in a serial or in a parallel way. And this is basically to compensate for atmospheric effects. So there might be, things that impact the performance of FSO. We can activate radio fixed wireless or vice versa. Optical spectrum as a service, on the other hand, helps a lot to reducing possibly the cost and the energy consumption. We have a lot less equipment that is needed, but it's a very challenging type of solution because then we need to be able to have it running in legacy network and network in operation without disturbing the existing traffic. So, power compatibility issues will be important to see. And we will use fiber sensing to actually monitor network condition, but not only that. So not only understanding if there are anomalies, possible failures that will require an intervention on the traffic, but also looking into if it is possible through fiber sensing understanding something about the weather conditions so that we could also steer the wireless resources. And of course, we will use optics. So we will also to develop control and management solution that are slightly different from the legacy one, because in the legacy one, we have wireless and optical controllers that are usually separated. But here, since we want to make service provisioning decisions that are based both on the wireless and the optical transport resources, and possibly configure one with respect to the performance of the other, we need to bring basically the optical agent into the, let's say, the conventional RIC, if we refer to an open ORAN architecture. And then on top of this, we will build a monitoring function and then, possibility to steer and reconfigure our confluent mesh using artificial intelligence. So just to conclude, I put the final objective that was stated in the project here. I already discussed about which are the technology that we would like to look into. I already discussed what might be the challenging, but you see the list, more detailed list here, what the control and management framework. Of course, we will also look or try to look into proof of concept demonstrator, especially this hybrid fixed wireless and free space optic transmission. We will see, or we will demonstrate, or we will aim at demonstrating how we could use fiber sensing in order to steer the resource in our confluent edge mesh. And also we will demonstrate the energy and latency performance of the system. And just before concluding, this is the structure of the project, but is nothing surprising or new. Work package on the service and architecture, two technical work packages, one more on the transmission technology, one on the control and management, the work package that will deal with the proof of concept demonstrator, and then project management and dissemination. This is it. So if you have any question, I will be happy to answer afterwards.